Hey everybody, it's Chris from GreyBeard Wi-Fi. Hey, thanks for joining me today, and thank you for your patience. I've had a lot of things going on in my life away from GreyBeard Wi-Fi that has been taking up a lot of my cycles. Some of it, stay tuned. It's going to be very interesting for you, and might even be able to help you out with doing stuff Wi-Fi. I always wanted to check out the ability of a Raspberry Pi and the distance it can go. And this is going to be a raw video. There's not going to be a lot of polish to it or anything like that. This is just more for some fun and just to kind of check out to see what some of the performance is. My plan is going to be that I've got an AirCheck G2 from NetAlly, and I'm going to go 30 meters, 100 meters, and about 150 meters, and to see if I can connect up to the Raspberry Pi. And like I said, I will show it to you in a second. And what the goal is to see if I can authenticate, associate, and get an IP address off of it. So let's have some fun, enjoy the weather, and let's dive into it. Okay, so for this experiment, what I'm going to be using is I'm going to be using a Raspberry Pi 4. It's got an aluminum case around it because I am going to be taking this out to the field to do parks on the air and other activities in my amateur radio world. So I needed something that was quite rugged. On top of here, if you see right there, is T2U from TP-Link. So it is an 802.11 AC capable adapter, but for this experiment, as I mentioned earlier, I'm just going to be using 802.11a, channel 36, just going to keep it very simple for this. Also as well too, I've got a solar battery bank in order to operate the Raspberry Pi. So all the parts and pieces that you see here for this experiment, I will have Amazon affiliate links for them in the description below. I get a cutback from the sales of them, so it will help me out and I will be able to produce more videos like this. Okay, so what I'm going to do is I'm going to set up a baseline here. I'm right beside the Raspberry Pi with the adapter. And if we could take a look, about minus 31 dBms with a 61 dB signal to noise ratio. And what I will do is I'll do a quick connect to just confirm that we've got everything all set up. So I'm just going to press connect. Okay, we established a connection, so we authenticate associated. We got an IP address, the DHCP server and the gateway are all embedded into the Raspberry Pi, no problem. And it's not connected to the internet, so I'm not going to worry about the second DNS or finding the actual target itself. So what I'm going to do is I'm going to stop, scroll up a little bit. Here's our physical rates here, 54 megabits per second. Yes, I am running 802.11a. I'm just going to keep this simple. Like I said, this is going out in the field for my parks on the air for my amateur radio life. So let's go and move to our next point where we're going to do our measurement and see what happens. Okay, I'm approximately about 30 to 35 meters away from where the Raspberry Pi acting as an access point is. And if we take a look here, we've got a signal level of minus 70 dBms with a signal to noise ratio of about 21 dBs. And so what I'm going to do now is, with one hand, is do a connect test. We're able to connect up to authenticate associated. We've got an IP address, found a gateway, which is going to be our access point. And let's take a look. So we still get a data rates of about 54 megabits per second, so not too bad. And a signal ratio now of about 27 to 30 dBs. All right, I'm going to go to about 100 meters in that and see what happens. Okay, so I'm approximately 100 meters away from where the Raspberry Pi access point is. And so let's take a look. It's substantially dropped down. So minus 85 dBms. We only have a signal to noise ratio of about 8 dB. So not really that great. And so I'm going to do a connection test and see. Let's see if it connects. Hey, we got it. We authenticated and associated. Got an IP address. Of course, the DHCP server and the gateway is found because that's what it is, and same thing as the DNS. But let's take a look at our data rates. Look at our data rates right now. 12 megabits per second data rates. We had a maximum PHY of 54, but it's dropping. It's now 9 megabits per second. Signal level minus 92 dBms right now with a noise level minus 100. Signal noise ratio 13, so it's dropped substantially. So I'm going to go about another 50 meters and see what happens. Okay, I'm about 150 meters out and it is very weak. Signal noise ratio about 8 dB. I have seen it drop down to minus 100 dBm, so very, very, very weak. And so what I'm going to do now is I'm going to start walking towards, back towards the access point. I know it's going to be shaky, so I apologize for that. I'll try to go as slow as possible and just start seeing. So I just walked about 10 meters closer and we're starting to get pick up some signals here and see what's happening. So we're now coming up to about 125 meters away. And let's do a quick connect test from here. See what happens. We got authenticated associate, so we established a connection. We're getting an IP address. So we're about 125 meters away. I'm just going to scroll up. Yeah, about 18 megabits per second. Signal noise ratio is bouncing between 8 and 11. So 8 and 11 dB. So yeah, we definitely, could this be used? Perhaps. But not really optimal for what we're going to do. All right, I'm going to head back to the headquarters and then we'll do a little bit of a debrief. All right, so a little bit of a debrief just on this, like I said, raw dog, sort of just go out and just give it a try sort of thing. I would say that the performance of this, it went out a relatively good performance, would probably be between maximum 50 meters or so, and then it really starts dropping off. Now, there's a lot of things that are at play here that could affect the performance. There are trees in the way, there's vehicles going by, there's other Wi-Fi that's around that's going to cause some interference with regards to how this performs. As I mentioned, this device here, I'm going to be using it in my ham radio world, and I'm going to be setting it up outdoors in parks and places like that where there might not be as much interference or noise when it comes to those locations. Now, a couple of things here. This was outdoors, it's not indoors, so we can't make the assumption that this is going to perform just as well, indoors as it does outdoors. So because indoors we've got walls, we've got other types of interference that's in there, we've got the effects of those walls and such things as reflections, refraction, absorption. There's going to be multipath that's going to be in there, and so on and so forth. Would I use one of these as a replacement for an outdoor wireless access point? Absolutely not. The Raspberry Pi is it's a great computer, but it does not have the horsepower in order to support many different clients being able to authenticate and associate to it. This particular device here, there might be a maximum 2, maybe 3 devices that are going to be connected up to it. So that's why I'm okay with this, okay with the range. Definitely got a reason to go outside. It's a beautiful day out today and got to definitely enjoy this. So speaking of enjoying this, if you did enjoy this, I recommend that you make sure that you give a like, to do the thumbs up. Subscribe, because as I mentioned earlier, there's going to be some announcements coming up in the near future about what's going to happen with this channel and what's going to happen with me as well too. So there's going to be a lot of exciting things, and maybe even some things that are going to help you out in your Wi-Fi journey. Make sure that you do hit the bell notification so that you do know when there's new videos coming out, and so that you do get that information. Okay, I hope you enjoyed it. I did. It got, like I said, it got me out of the office, and so had a little bit of fun. All right, so thank you for joining me today, and I hope you have a wonderful day, and peace.